It's all Dutch, but you are not. So you have to do it in English. Sorry, I'm a bit tired. Okay, ladies and gentlemen, this is Matthias Strubel from Germany. He's going to talk about Hacker Meets Mainframe. I'm really looking forward. So Matthias, give him a big round of applause.
Yeah, hello everyone. I'm super nervous, so I'm sorry when I start to struggle. First question, who of you ever heard of Mainframe? Okay, nearly everyone. Who of you ever worked on a mainframe? Okay, and who of you ever seen a mainframe in person? Oh, even more, that I didn't expect that, okay?
You may not touch the mainframe.
So, and who of you think the mainframe is in your daily life? Oh, okay. It's in your daily life, so you get in touch with it all day long.
Currently, or?
Not about currently, but more like, okay, when you do your daily work, like buying something or whatever. Yeah, so mixed. Yeah, somehow, okay. So, yeah, I'm Matthias Strubel, I'm from Wiesbaden, Germany. I'm working on the topic Linux and mainframe and integration of those using integration techniques like message queuing. Since 2012, I'm a freelancer. And I'm the lead developer of the Pirate Box project. I have to admit that this year my fate was a bit strange. So when I submitted this talk in January, I didn't know what happened to me 4 weeks ago. 4 weeks ago, I'm now allowed to work at the research laboratory from the IBM, directly with that Linux. So you will find a few slides from the IBM in my presentation. And in addition, I need to get some clearance for this presentation. That makes me even more super nervous. So yeah, so that you have an idea. Okay, that guy is not only here in terms of his private person, but it suddenly starts to mix up with my daily work. So yeah. Okay, when I first met the mainframe, it was when I started my apprenticeship at a huge insurance company when I was 20 years old. And my first hit to the mainframe was when my 4 colleagues, my apprenticeship colleagues, and I went through the different departments, IT departments, to see where we're going to do our apprenticeship. First we go to the web developers with a fancy big poster at the slides showing how the website works and whatever. And everybody was like, wow. Then we went over to the call center software, C++ application, and everybody was, wow. The next step was to the electronic document management, and it was already like, because there was some kind of mainframe thing. And then we went to my department, and oh my God, it was mainframe. And I started an application program in COBOL, doing maintaining and developing an application which was older than me. And as a side fact, the oldest program I had in my hand was 5 months older than me. So anyway, everybody was like, oh my God, we are so sorry for you after this presentation. So that was my impression how a mainframe looks like, and I want to start to get into the topic with a small video. Okay, can't hear anything. Yeah. stop here before the fun part comes. So this is something what you can imagine how a mainframe daily works as a system programmer looks like. Now, what I've seen is are the most common things like which you find today in a mainframe, like punch cards and whatever, but we come to that later. So there are some prejudice about mainframe, like mainframe operators are very old, having crew here, big classes. Well, okay, I have crew here, but I'm not that old. I'm about 31 years old. So, but yeah, I work with mainframes. The next prejudice is mainframes are huge computers and huge data centers, big rooms with a lot of cables, and they are all using very old techniques like magnet disks, magnet cassettes, magnet bands, and of course punch cards and punch cards reader and printers. And yeah, and the most common prejudice is this one. The mainframe is very expensive, has high licensing fees, and yeah, the IBM rips you off your money. The next one is, I assume a lot of you think, okay, the mainframe only runs on proprietary software, and there's only proprietary software and old legacy applications running on there, and it's very restricted. And you always have to pay licensing fees for your software you get, and you can't get something for free. So, and I try to sum up a bit where the mainframe comes from now, and then we are going to see how much of these prejudices are true or not. Yeah. But back in the days, 1964, the mainframe was not only the mainframe, the let's say big computer century started, and there were a lot of different big computers and big boxes. They all worked different, and they were incompatible to each other. And in 1964, IBM made a release, and it was $1 million bet. They said, okay, we are releasing a system which fits you all your needs. The system is called S360, 360 like the clock, and that's the name because it should fit for all your needs. And they designed a 24-bit architecture. Remember, 60. We are talking about 1960. Yeah, 24-bit architecture. What they did a proper documentation of this architecture and claimed, if you buy the next release of this hardware, you can take your source code, put it on a new machine, and it will run. So these architecture definings are still valid today, and you find it in a book called Principle of Operations. This is that much big, and it's very hard to read, but you find everything from the hardware to the software layer about this topic. Now, what was so outstanding at this time for these machines? This is a draft, how the architecture overview of a mainframe is, and it's at one specific point very different from a normal Intel architecture, and this is this area here. While on a normal Intel CPU system, the CPU is doing the I/O, and some cards have direct memory access to write data in the main storage. On a mainframe, it's not like that. In a mainframe, you have so-called channels, which are data lines directly to the CPU. And if a program wants to read something from a disk or from a punch card reader or whatever, it calls across some of these channels a channel unit. This is a separate processor. And after he called it, that I want to get a file from this disk or a record from this disk, the CPU comes back, and this program is set beside in a wait state, and the operating system switches to a different task, and the program waiting for the input stays beside a long time until the channel unit was able to fulfill this I/O request, and then it pushes an interrupt into the core from the mainframe, which leads the supervisor or the operating system to get later back to the task, which is waiting for the input, and proceed the I/O request. And that brings us to the most important part already at that time that the IBM architecture is not a number cruncher architecture, it's an high I/O bandwidth architecture, which allows you to run at very high CPU level, because it's not the main CPU is not taking care of the I/O work. Already the first models since then had virtual memory management in terms of not using real memory but having page map tables. So at this time when main storage was very small and the main storage was very expensive, the IBM already implemented features to circumvent problems of this, and at a time where no personal computer exists, the IBM used and the NASA used the mainframes to fly to the moon with the Apollo 11 mission. Besides of that, at the Apollo 11 mission, they used a database system which is still active today. It's called IMS, it's a hierarchical database, and it was invented around the Apollo missions. So back in 1970, when the first personal computers came around, the IBM was already playing with logically dividing the hardware into slices, and so while others were happy to run their workload somehow, the IBM was already taking care of ideas like, how can I virtualize logical partitions or create logical partitions on my system? So they invented features like Prism. This is a hardware and firmware-based virtualization in logical partitions. In terms of security, these partitions still today count as two separate boxes. If you buy two Intel boxes and set them next to each other, it's the same. It's technically, in terms of security, the same level as having two alphas. And the next thing is the ZVM. Already at this time, the IBM developed virtual machines, so they have now over 40 years of experience in virtual machines, while the Intel first software VM came out at 1990. So here's an overview a short overview picture about these virtualization techniques. So you can create up on the hardware 83 logical partitions, and one logical partition can be a ZVM, and a ZVM can run hundreds of virtual machines, and inside the ZVM machine you can launch another ZVM machine. So you can create cascades of virtual machines, and so you can stack up your test environment and whatever. So what operating systems can you run today on a mainframe? On a mainframe, the most common operating systems are those two and those. Yeah. ZOS is the operating system from the days when the architecture was invented. Z4SA and ZPDF are specialized operating systems, some kind of. ZPDF is for very high transaction rates, which is usually used in terms of flight directing and reservations. And you can run Z-Linux. I come back to that later. And what I really want to stress is that since the 90s on ZOS there's a POSIX-compatible Unix part called Unix System Services, where you can just already today run your Unix POSIX-compatible software inside the ZOS. When we are talking about ZOS, it's a total different architecture compared to a normal Intel operating system like the normal Linux and the Windows and whatever. What the IBM brought into the race in the 90s was something called Sysplex. This is a very mainframe specific thing. This is again a slide out of the introduction books from the IBM. So that's called Sysplex, this feature. It's a very technical thing. You have this logical output, this logical physical machine, and here you have these channel exits which are connected to channel units. Or they came to the idea, okay, what if I connect an alpha through a channel to another alpha, so I can make those two boxes connect to each other, and those boxes can be virtual or physically. So you can have here at this line, maybe 20 kilometers. And together with this coupling facility, this is a special programmed virtual machine or physical box, which is mostly memory. Those two logical partitions are able to communicate and work together as only one machine. And in case of an outage, if you configure everything, this box will take over and work like there are only one machine. So now we come to the question, but where can I find the mainframe today? So the easiest thing is banks. If you go to the banking terminal and want to get some money, at the banking terminal they run Windows XP mostly. But the software running on the banking terminal is mostly only a front end and connects to the back end with techniques like message queuing, mostly IBM message queuing. And if you enter your PIN and this EC card stuff is recognized, they are sending a request across the network down in a transaction monitor system. On the Java workload, you would say it's a Java virtual machine or it's an JBoss or whatever. For old legacy applications, these runtime environments are called KICS and IMSDC. So there's running an old legacy COBOL or C++ or whatever program, and this is called getting the data from the DB2 database system or from old hierarchical database IMS. Yeah, and COBOL and PL1 is still common at these days. So then we have travel and ticket management for booking flights. That's mostly at the back-end mainframe. Especially Deutsche Bahn is running a huge mainframe infrastructure, and last year I stumbled over a web page. They were able to check out the days when a specific ICE train drives. So some trains are only driving from Monday to Friday, some trains leave out Saturday, whatever. And per accident I discovered at the bottom of the page there was a small ASCII art printing in the size where normal a terminal would be. So some guy coded a terminal screen capture, make the pretty interface on top of it, and forgot to comment out at the bottom that original output.
It's still there, and it's in the main interface of the Bahn website.
Yeah.
And it's you only see it when trains are running on irregular days.
Okay.
Or when they're running on, let's say, 5 days a month or 9 or whatever, and then you can see exactly when it's running.
Yeah, exactly. That is the thing. Yeah.
But it's in the people's interface. It's
yeah.
The same as they have on the screen. They put it to the website, and it works.
Yeah, of course. And it's even more often that, especially at the beginning of the web, that application developer and web developer wrote something like screen scraping, that they open up a virtual terminal against the mainframe, scrape the screen, get all the data, put it on the web front end with a very nice interface, make a form, and then you enter your form data, and they fill out the form in the back end at the mainframe screen, submit like a normal user would do, and then process the input. I hope those days will end. Okay. Next, yeah, of course, that's the problem of legacy application. It's paid and it works, and then nobody wants to change it. Anyway.
The other problem is when you want to change it, you have to reprogram the COBOL to make a nice message queuing interface. So the web front end can talk to it instead of the terminal.
Remind me about this. I can give you an idea how to do it without changing the COBOL interface.
I have also some ideas, but
I have no ideas. IBM already have a solution for this.
okay.
Kind of solution. Then the next step is industry and logistics. Last year I was able to do freelancing at Volkswagen, and they are running the stock management, like which part should be at which position, the production line at which time. Oh, this was wrong. So you have a part in a stock, and the car comes across the line, and they do just-in-time delivery. Then when it comes here, the correct door is already there. And to do this, they are doing this real time, and they're doing this using an infrastructure with a mainframe application, message queuing, Windows servers out there, and somewhere in between is SAP as well. So
it's even more expensive.
It's even more expensive, yeah. Yeah. So I don't know if Amazon is running like this, but in this kind of logistic things, it is very common. Or the smaller versions, this AS400 is common as well. So and then smartphones. Smartphones? Yeah, still, if you're doing your online banking on your smartphone, yeah, when you check your bank account with your fancy smartphone application, as we just discussed, it's still running against the mainframe backend again and again and again, and creating load at the backend. So you would be really surprised how much is running in the backend on the mainframe. Okay. Next step, and this next step was somehow important for the IBM as well. They opened up for Linux in the year 2000. 2 years before the year 2000, a few guys did together in the IBM lab in Böblingen secretly and start to port Linux on the mainframe. And at this point, when they released it, it was like if you say it's a mindset change, it's suddenly, but it's the beginning of a mindset change. So on the one hand, it was a big risk to open up their mainframe application, their mainframe architecture and system to an open world, or open software world. But in the same moment, it opens up a lot of possibilities. And when we are talking about Linux on the mainframe, this slide is very important. Linux on the mainframe feels like a normal Linux. It is a normal Linux, only a few percentage of the kernel code, and this is very low, below 10%, a lot lower than this, is relevant for the device drivers. There are special device drivers, of course, to support the old disks, the old protocol, and the architecture of the mainframe. And you can attach normal SAN servers as well, so it totally feels like a normal Linux. You only have a different boot up procedure, of course, because it's not a BIOS, but it's just running. So, but it is like a normal Linux. So, and officially, the IBM works together with SUSE and Red Hat. So, oh my God, it's the Linux. Everything can run. Yes. The thing is, the IBM works together with those distributions, and the most important thing is to say is, first of all, a mainframe customer is still a mainframe customer. And when I talk about mainframe customer, he stands for stability, reliability. So, and this is something which the IBM offers with those two distributions. They say, okay, when we deliver a new hardware platform like the new Z13, we have regression tests, and we guarantee that those two distributions are working on this platform. And if there's a bug because of the hardware change, we are delivering patches for the Linux kernel together with the distributions. And there's a lot. That's not how much I can tell you about this. There's a lot what the IBM does together with those two distributions. Don't underestimate what's going behind. And when I talk about the cultural change, the other things pop up. You are able to run PHP on the mainframe. What? PHP? I'm not talking about PHP in Z Linux. I'm talking about PHP in a ZOS environment. In the old traditional COBOL ZOS environment, you are able to run PHP. Of course, Java. I have no picture for Java because so everybody can imagine, yeah, not Java. Java works on ZOS. Java works in Z Linux. And they're working on integration on OpenStack, and I saw a presentation 2 weeks ago from a colleague who's deploying live into a virtual machine on his ZVM, and it comes up with a WordPress. So what? And about this topic, how can I apply a web application against an old COBOL infrastructure. If some things are valid for this environment, it is possible to enable an JSON to COBOL structure mapping. So you send in a specific JSON structure, and the kicks has a module which allows you, if it's correctly configured, in terms of having a RESTful interface, to transfer this JSON structure down to a COBOL structure and call your COBOL program. So they are doing a lot in these kinds of things. Yeah? And with new workload, this is how the IBM calls this new applications running on the mainframe. They recognize, okay, we have to do something with the CPU. The first CPU wasn't that good for the Linux application, because you have to keep in mind, this is an architecture that came from the 60s, 70s. You have applications which are very, very highly optimized for the platform and on running on those platforms at a pretty low level. And even assembly is running today, which is since 20 years without any change, because it works. So there was no need to big changes in the CPU, but with the entry of the open world on the mainframe, the IBM decided, okay, we have to do more. We have to do more in terms of, well, this CPU is not like a mixture like the X architecture with having a part of a 6 kicks, complex instruction set, blah, 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 and small instruction set. No, every command is natively executed on the CPU, so you have, in this principle of operation, such a huge list of opcodes which you can code in assembly for a specific task. For instance, with the new set13 architecture, you have a whole new set of SIMD instructions which are built in the CPU. This is for matrix multiplication and this kind of stuff. And you gain some performance proofs per each architecture since 2000 because of these new CPU opcodes, which can be executed and are better supported with newest cache structures and so on. Okay, let's come to the prejudices. Old man with white glasses, with big glasses and white hair. Okay, I'm still cool, but to be honest, my personal hero is the woman on the right side, the left side. This is Isabel Arnold. She is one of the key players in the Kicks team, this transaction server. She is my age, and she works because she came after her studies to a team of old crew people, and she mixed them up, and now you can configure Kicks using Eclipse, an Eclipse-based environment. And she's giving talks on universities and so on, and you find her on some marketing posters as well. The companies discovered that there's a gap in 10 to 15 years. No, sorry, there's a gap of 10 to 15 years where they missed to educate new people. So in the next 5 years, a lot of mainframers go into retirement. But okay, they leave some young people, but not enough. So, and with that, the companies recognize that this is really an issue. This is really an issue. Some new companies pop up, like the EMA. It's called European Mainframe Academy. They are doing a 2-year besides job study and educate a very hard and tough program to get the people into ZOS, into the mainframe architecture. And they make a good job. I'm doing a beside job study on them as well, and then I will be done at February next year. And you get a huge stuff to know, and you get very used to all the IBM stuff. So they are doing a good job. So it's not all to summarize. Yeah, they are old men, but a lot of young people are already there and are already running across the lab. Yeah, huge computers in big rooms using old techniques. Okay, I have to admit, these punch cards, if you boot up ZOS Linux, you set up a virtual punch card. Okay, it's still there, but today mainframe, okay, now I have to look at the slides because they are so small. The machine is called Z system. Z stands for nearly zero downtime. And that's not only a marketing gag. Point is that this hardware is fully redundant in terms of hardware. The hardware is built in a way that if it detects a failure, it's possible to move the workload to a different CPU or different memory ranks. As I mentioned, these certificates numbers, I don't want to talk much more about it. The current CPU is running with 5 gigahertz. The previous model is running with 5.5 gigahertz. And you can stack up Z13 with 10 terabyte of RAM. Yeah, and there are 141 CPUs you can staff it with that. That's a huge amount. And remember, you're running a much higher workload on a Z platform than a normal Intel system, because it's built for overcommitment of CPU and overcommitment of memory in a virtual machine. And in addition to this 100 whatever CPUs, you have these channel control units. Channel control units, we remember, these are the things doing the I/O with the world outside this black box. I'm not moving. Then you have other facts like Icon Express for connecting to the storage. And you can plug crypto acceleration cards and crypto key cards. In terms of cryptography, you have the possibility to store keys in there, and they don't leave the box, and they don't leave this card. And on Z Linux, you have special infrastructure in libraries which directly speak with those cards, so these keys never leave these crypto cards. And if you open those boxes, they delete themselves. Yeah, and Z servers are available in enterprise classes. These are those two-sided boxes. And in business class models, those are one boxes. And now I have a picture it's from Wikipedia, but you can see that in the lab. You can visit the lab, and in the area directly in front, when you come into it, there's then those two machines. Currently, this is an old picture with the previous module. Now there are pictures from there are the boxes from the Z13. And what you can see here, I just want to show you how much hardware is in there. This one is a so-called book. You can compare it with a mainboard full of memory and the CPU. You can roughly see here cables. These cables are connected to a management unit. So you can imagine the mainframe is like a big steam tanker on the ocean, and to manage this big tanker, in those two boxes are management units connected like with an additional network with Power 5 processors managing the hardware to keep it running and to watch that everything is working like expected or initiate a failover. I think this is an air-cooled machine, because here, this are the heat exchanger. You see here some sockets where the books are connected to, and the water is circulating here. And you are able to connect the mainframe to your building heating. Yeah, it's no joke. So you can, and my former employer did this. He connected the water cooling of the mainframe to the heating of the building, and then we used the wasted heat energy to heat up the building. And we are talking about kilowatts, you know. Here down there, you can put the extension cards. At the top, you have batteries. If in case of a power failure, you have the possibility to make a clear shutdown. Remember, it's all inside and built in. And here you have the networking cards and all these stuff with communicate with the SAN servers and whatever. And before I forgot it, they do earthquake tests. Remember the big earthquake with the tsunami in Japan? I saw a picture of those two boxes flipped beside each other. They were keep up and running and run all the time because the cables were long enough, and the mainframe is tested on shaking platforms like satellites, that in case of an earthquake, the cards won't lose their connection. So they are not normal PCI connections, so those were very tough connection pins. And yeah, the box went down when the guy came in and said, oh my god, the mainframe, and put the switch off. That's how it works, you know. Yeah, there's a big, what you see here, this is the emergency off. Just, if you see mainframe, no, don't do this.
It's the early contract termination fee.
No. One thing I forgot to mention, usually there's a ThinkPad directly connected to the machine. It's so-called the management box, or the service computer, which is in direct contact with the box, managing the hardware management console. The hardware management console is the thing which is organized the L power, and there you can just turn it off and on. Yeah. And there's no storage included, so you have to buy an additional storage box. Okay. That brings us to the next topic. It's just expensive, yeah. It's expensive, but yeah. Content is. First of all, you have to think about there are applications which run there for 20 years and they have to run 10 additional years. That's the first thing I want to mention. So if you have a bank, they have law regulations to not throw away data in terms of time. So sometimes there's a need to keep this box running because of these law regulations. And of course, sometimes the application is still valid and does their job, so why recode it? So there's no reason besides the knowledge thing. Then remember, in terms of expensive and money, the question is where you pay your money to. First of all, you have, especially companies like insurance and bankers, you have requirements by the government how you have to protect your data in case of a disaster, like an earthquake or like fire in the building or like a bomb falling down on your data center. So you have to spread your data across several kilometers. Yeah, you can do this with open source as well, no problem. You can do this with sound management, blah, blah, blah. But when it comes to how much costs do you have to put into this to realize this open source software and manpower against paying the license fees, it's very hard to evaluate. Especially if you put more hardware on it, you have a higher mean time before failure in terms of you have more hardware which can fail. In the mainframe you have around, I forgot the number, I think it was 30 years of mean time before failure, before the hardware box goes black. So, and this is the average. Yeah? So normally the box runs much more longer, and because you have service contracts, it happens that the IBM technician calls you or rings the doorbell like you have a problem with your box before you even recognize there's an issue. And the IBM has products that you can achieve these law regulations very easily or relatively easily, and they have experience of over 50 years doing this. Remember, they are a very old company in this kind of thing. In terms of money, it can be cheaper to say, okay, I want a Z system with virtualization to reduce my cable and data center footprint. I have here one sheet from the IBM. There's one customer, he had this kind of network with over 600 cables and guys running across the data center checking it's the right cable and it's probably fit. And then in addition to this, remember, sometimes a cable fails. And a cable may fail not in terms of the light goes out, but in terms of works, doesn't work, works, doesn't work. So, and after his consolidation, running everything on the Z platform, there were only 10 cables left. And I mean, this is something pretty cool, I think. My last slide from the IBM about costs is this one, mostly because I usually forget it. Because I'm not that close to software licensing. The thing is, what I would point out here is, especially with Linux consolidation, you can achieve a reduction of your IT costs. Because remember, some software is paid per core, and if you run an Oracle server on the x86 platform, let's say this server has 8 cores, and you have this Oracle machine sitting there doing nothing because it's a test machine. You pay for 8 cores. Let's say 1,000 per course and 8.
Machine, you don't need a valid license.
Depends on what kind of test machine you have and with
it's only a virtual case to explain how the cost structure can be. It's only a can, you know. I know that, and this is one of my last sentences. Yeah, I come to the point now. The thing is, if you run with the same performance and overcommitment and blah 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 in a ZVM with only 1 core, you pay for 1 core the Oracle license. The 1 core maybe is a bit expensive than 1 core on the x86, but overall it's cheaper, and you have a smaller data center footprint. So, now come to the point about the costs. I'm pretty sure it's not like that. Shut up and take my money, and you shouldn't do it like this. Yeah. The thing is, especially when it comes about consolidation of Linux machines. The top 100 mainframe customers, 80% of them run Linux, because they consolidate all the x86 machines down there. That reduced their costs, and the break-even point for a small Z machine can be around 80 machines, 86 machines, 80 machines with x86 architecture. So, but the most important thing is, it's not always about the costs. Downtimes can cost more because of hardware failures, and as I already mentioned, you have non-costly requirements, and the last sentence about costs is, it depends. If you really have interest in doing this for your business, call the IBM and discuss it. The prices on the websites are okay. Yeah? The next thing is, what's about closed source software? Yeah, well, I think with opening it to Linux, and you can run Linux on System Z machines only on a box, and there are special contracts for that. You don't have to run proprietary software. And remember, Linux, PHP, Java, JSON, or your favorite language can run there. So I don't think this argument is that much heavy anymore. So if you get somehow interested into this mainframe topic, and even if you only want to know something more about the architecture and whatever, I totally can recommend those 2 things. The red books are called Introduction to the New Mainframe, ZOS, and ZVM Basics. This is the second version of the slide. I had in the first version much more technical details, and you can find nearly everything here to get a good overview and to get down into the topic, because it drills down at specific points. And overall, if you want to get into the ZOS topic, this one. A series of maybe 15 books explaining every sentence. In addition, you have reference manuals. The IBM documentations are very good, and this is something I can say since 5 years. It's already really, really good. So, Linux on mainframe, or the mainframe in general, is not one size fits it all. Yeah? If you need reliable results, not like Google, entering a search term like Pirate Box, and you get hit A, B, C, and the second time you enter Pirate Box and you get A, C, D. This is no reliable result. But in terms of banking, you need reliable results like your bank account sheet. This is something you should think about. Yeah? Downtime because of hardware failures is minimized to an absolute lower limit. And sometimes law requirements can be really, really important. But I think, especially with the Z Linux topic, and it feels totally like that when you get the first hands on it, it's more alive than it was 10 years ago or 15 years ago. Because there's much more movement also in the IBM. So that's about the mainframe talk. Do you have any questions?
Have you ever played with student mainframes based on our VDB 2000?
Nope. I had no chance to. Sometimes, yeah. I don't have one at home, so that's a problem.
You can run it in Hercules. Well,
Hercules, that's a good point. I was just thinking there was something I forgot. There's an emulation called Hercules with a big H, big green H, where you can Z Linux and you can a free M4S on it. And this is a very old, it's a very old MVS, so it's not totally representative, but yeah, if you want to, I used it to run my first set Linux on my box at home, a Debian, by the way, so that you get an idea what can be run.
I have a question myself.
Yeah.
The bank I used to work for, they had a mainframe, IBM, and the end of the year runs, it took a lot of CPU power, and we were able to like buy CPUs for a certain amount of time. Yeah. They were already in the system, and it required a floppy disk. You put it in, and then there were like 8, 16 or 24 CPUs were enabled for like a period of time. Is it also still available in the new Z systems?
Yeah, definitely.
So you always pay, or at least you always get some more processes in there already, and you can adjust them.
Yeah, and I didn't want to stress those topics so much, because I only gave 1 hour talk, but I can, I think, talk 5 hours about the CPU unlocking. That's something my old employer did too. So at the end of the year, usually you have, for instance, if you have a car, you get car insurance letter about what you have to pay next year. Then this is something that really took a huge amount of CPU to calculate this in upfront and create printouts. And you can, with a simple click, with some whatever, you can unlock CPUs which are inside the box, which they are spare CPUs in case of a failure, but you can unlock them to a certain limit. And as we saw, this box, in this clear case, there were only book in it. There was only one book. And usually a company has 2 books, because you may have a book failure, and in case of a book failure, the hardware flips over the workload to a second book, and these books you can just unlock for some reason if you need it.
Okay, cool. Any other questions for Matthias? Yep.
Too early. Sorry to bore you.
IBM is always associated with mainframes, but are there actually other companies making something like this?
Okay, good question, very good question. Currently there aren't any companies anymore. The reason is because it goes too expensive. The IBM puts billions of dollars in hardware development, and with the come up of the CMOS technology back in the 90s, it suddenly gets too expensive to the competitors. I had in my lecture I do from the Beside Job study, there's one guy from one of these companies, and they built long time compatible mainframes, but no, there isn't anything anymore.
Yeah, there were a lot more. Boole builds some hardware compatible and more software compatible mainframe parts and systems, and Siemens built, which was almost assembler compatible to the IBM. And they both killed it. Yeah. Siemens still delivers if you want, but they're not doing that much of selling anymore.
No more questions for Matthias? No? Well, thank you.